Section 23.3. This is about internationally integrated capital markets. And to explain this part, I'm going to refer to the problem or the exposition that is outlined on page 712. So what it says is that you are looking at a share of a British company, Vodafone, that is expected to have a value of £181 a year from today. So a year from today, you are expecting Vodafone to have a price or a value of £181. Assuming that the appropriate cost of capital in pounds for Vodafone is 13%. Assume that. Then what is the value of this investment or this stock today? And the answer is the present value, which is going to be future value divided by 1 plus R. Future value is 181, R is 13%. So that gives us a present value of 160.18. That's the present value today, 160.18 in pounds. If you are a US investor and you want to invest in this stock, how much would you pay to invest in this stock today? You are a US investor, so you have to buy this stock in US dollar. In US dollar, that your investment would be 160.18 multiplied by the spot exchange rate. Assume that the spot exchange rate at time zero is $98 per pound. So I multiply that by $98 here. That gives me a dollar value of 317.16. 317.16. That's the value at time zero in dollar. So in pound, the value is 160.18 in pounds, and in dollar, it is 317.16. Now, the US investor that purchased this stock at $317.16 will have to, is expecting that the value of this currency will rise over here in the future, but then they have to convert this into dollar. They have to convert that into dollar. What would that look like? So assume that the forward rate today is 2.02 per pound. That means the transaction that is made at time zero for currency to be delivered at time 1, that value is the forward rate at 2.20. So I will receive the 181 pounds and I will convert that 181, I will convert that into dollars by multiplying that by $202 per pound. Of course, the pounds will, do it this way again. So I take the pound, which is 181, I multiply that by $202 per pound. Of course, the pounds cancel. I'm left with dollar. The dollar value that I'm left with is 365.62. So for this 317.16 to have a future value of 365.62, what would be the discount rate? What will be the IY? So now so this I will enter as my future value. 317.16 I will enter as my present value. N is equal to 1. If I calculate IY, I get that as 15.28%. So if the pound interest rate was 13%, this 15.28 is the interest rate in dollar. If those are the rates that are applicable in the market, then we will say that our international capital markets are integrated. And the way we get this, we take the exchange rate initially, which was 198. Here it is. 198, which is the spot rate, multiply by the present, this is the future value. So 181 is the future value. This is 1 plus the pound interest rate. And this is the spot rate. So all of that gave me 317.16. On this side, I have the forward rate. This is the forward rate, F1. This is the future value in pounds. And this is the discount rate, 1 plus the discount rate in dollar. And all of that will also be 317.16. If those two things match this equality, then I would say that the interest market in Britain is fully integrated with the interest market in US. So thus the valuation principle that we're using here, that the dollar present value of the expected cash flows must be equal to what the US investor paid for in the security. That's what the equality is. So if I rearrange the math, then what I see over here is the forward currency is 1 plus the dollar rate divided by 1 plus the pound rate, the whole thing multiplied by the spot rate. And the spot rate is given in dollars per foreign currency, as is the forward rate in dollars per foreign currency. So this is the integrated equation that tells us the linkage between the forward market, the spot market, and the respective interest rate markets. If that relationship is held, then we say the international markets, international capital markets are fully integrated. If they're not fully met, meaning this relationship does not hold, another way to write this could be forward over spot equals 1 over dollar over 1 plus foreign currency, right? If this relationship does not hold, if the left-hand side and the right-hand side are not equal, then there would be a violation of this integration principle that would imply arbitrage profit potential. So here we have a problem. Calculate the present value of 10 million yens. The spot exchange rate is 110, so that's our S0. 1 year forward rate, that's our F1. Dollar value here, yen interest rate here. What is the present value of that 10 million from a Japanese point of view? So the relationship is forward over spot equals the yen, the ratio of 1 plus the yen interest rate and dollar. So the future value of 10 million, we take the interest rates, the forward rates, and the spot rate. And we put this into the equation. So yen cash flow divided by the yen discount rate multiplied by the spot rate, which is the yen cash flow divided by the discount rate multiplied by the spot rate equals this. Now, if you take the yen cash flow, apply the forward rate, and divide that by the dollar discount rate, you end up with this. So both are equal. So that means the markets are fully integrated. If they were not integrated, this number using the forward rate would be different than the number that I'm getting using the spot rate. Another way to put this would be I would simply take F1 over S, calculate the ratio of yen yen plus dollar, because exchange rate is quoted in yen over dollar. Yen over dollar. So I will calculate these ratios and check what this equality is. If it is equal, if they're equal, then it is internationally integrated. If they're not equal, then there is presence of arbitrage profit. You can work through similar problems over here to check for integration versus non-integration. Similar problems all the way through section 23. What do we do with foreign projects? We looked at net present value for domestic projects. How do we do net present value for foreign projects? Pretty much the same strategy. We start with sales, cost of goods sold, we get operating expenses, depreciation, calculate EBIT, then we add back depreciation, subtract capital expenditure, account for net working capital. These are our cash flows, but this time these cash flows are in pounds because the project is in UK. So to calculate the net present value, I will take each of those pound cash flows and I will convert them into dollar cash flows using the forward market. So I will use the 1 year forward market, the 2 year forward market, 3 year forward market, 4 year forward market to convert these cash flows into dollar values and then take the present value of those dollars. So I have the 1, 2, 3, 4 year forward rates based on what? Based on the current spot rate and the term structure of interest rate. So the 3 year forward rate will be the current spot rate, 1 plus the interest rate for 3 years, raised to the power 3, divided by 1 plus the interest rate for 3 years in pound, raised to the power 3, so I get the 3 year forward rate. Once I have the forward rate, so I have the pound cash flows, and I have the projected forward rates, then I calculate the dollar value by multiplying these two. By multiplying those two, I get the dollar value, and then it's just a matter of putting it into a financial calculator. So this would be your C0, C1, C2, C3, C4, and you will discount those at the dollar interest rate. And you already know what the dollar interest rates are. So you will discount them at the dollar interest rates, and you will be able to calculate. You will discount them at the weighted average cost of capital that we had learned earlier in dollars, and you will be able to calculate the present value of this British project in US dollar terms. So that's what we do over here. Based on the balance sheet, we get debt, equity, total value. So cost of capital for debt, cost of capital for equity. Then I have amount of debt, a proportion of equity multiplied by cost of equity, proportion of debt multiplied by cost of debt, 1 minus the tax rate. That's my weighted average cost of capital in dollar terms. And once I have, I take the present value. So this is C0, C1, C2, C3. I is 6.8%. Sorry, this is C1 actually. C1, C2, C3, C4. That gives me the present value of the future cash flow. I subtract that from the initial cash flow, and I get my net present value for the project. So pretty much the same net present value that we did before. The only change for an international capital budgeting is we project out the foreign cash flows exactly the way we would do it for a domestic cash flows. but then we convert those foreign cash flows to dollar equivalents using the projected forward rates. That's the key part that is different for foreign capital budgeting. And so that's where I will end chapter 23. I will not cover section 23.5 or section 23.6. I have covered already section 23.7, the capital budgeting and exchange rate risk. So section 23.5 and 23.6 will not be covered for this chapter, and that will end for us chapter 23.